There's a couple of problems from the book to illustrate the process of evaluating an integral, a definite integral, but using the U substitution techniques. So what we have here is this first one is integral from 0 to pi over 2 of this function inside there. So let's call U is equal to minus cosine theta, that's up here. So du is sine theta d theta. So that works out. Now we're going to switch over to the u limits, and we're never going to return back to the theta, which is different than regular u substitution. When you're just finding an antiderivative, you do return back to the original variable. Here we're evaluating at limits, so we can just switch everything over and never return back. So u limits, well, when theta was 0, u is negative cosine theta, so u is negative cosine 0, which is negative 1. When theta is pi over 2, u is negative cosine pi over 2, which is 0. So now converting over the integral, never have the original variable and u in the same integral, not even the limits. Switch them all over. So now you switch from negative 1 to 0. That's the new u limits. And you have your negative sine, negative cosine theta became the u, and the sine d theta became the du. So everything is switched over, and you just go from there like it's a new problem. You never have to think back at the original. So the antiderivative of e to the u is e to the u, evaluated at negative 1 to 0. So here you have your evaluation, and here's your exact answer right here. It would be 1 subtract 1 over e. Now let's check it. So to check it, we do the decimal approximation. Then we run the trap for 100 intervals for the original function. Of course, we have to use x's for the TI calculator. We use the x's. And run that from 0 to pi over 2. So you do it, you check on the original. The original problem, not the u part. Check the original problem. So you run that program, it comes out 0.6321, which matches up very well. So that means that you did the process right and got the right answer. Number 67, very similar. Let x plus 2 equal to u. So here you have the u. Du equals 1 dx, so du equals dx. The u limits. When x is equal to negative 1, u is x plus 2, so it's negative 1 plus 2, which is 1. When x is 2, u is x plus 2, so it's 2 plus 2, which is equal to 4. Now you're ready to convert everything over. The du becomes the the dx becomes the du from here. And the x plus 2 was the u inside there, and you have the square root. So the limits are now going from 1 to 4. So this is a brand new problem that will have exactly the same answer as the original. So you differentiate the square root of u, which is u to the 1/2, so it's u to the 3/2 over 3/2, evaluated at 1 to 4. So that's 2/3 times factored out of the evaluation. Stick in the numbers, work it out, you get 14/3 exact value. But for checking purposes, that's approximately 4.6667. Run the trapezoid on the original function, original, not the u, from -1 to 2, and that came out 4.666, 6, but it's there. It's checking. So that verifies that all your process was correct to get to the 14/3 exact value.